So what we have today is a little bit of a different presentation. We're going to talk about the DNS component in OpenStack, which is called Designate. And we have two speakers here, Stephan Lagerholm and Graham Hayes. Graham is on the core development team for Designate. And Stephan, I think, sort of modestly described himself as an OpenStack enthusiast. So he's going to run through some slides. I understand there is even a special treat, a bit of a live demo at the end. And feel free to post your questions if you have questions in either the chat or the Q&A at the bottom of your screen. And when we get to the end of the presentation, we will walk through the questions and let Graham and Stephan answer them.
Cool. Thanks.
So I think we're ready to get started.
Great. Well, my name is Stephan Lagerholm. Thank you very much, Vicky. I'm a DNS enthusiast. I started my career back in 1998. I think it was. It's kind of first time I started touching DNS. I think it was bind 8.1 at that point, but it might be 8.2. I don't really remember. And at that point, we were using Webmin. I don't know if you guys remember that graphical user interface to go in and manipulate DNS records and so forth. So that was fun times. And I've been working. I'm born and raised in Sweden. I've been working different companies running DNS. And today, for the record, I want to say I'm doing this talk on behalf of myself here, so I'm not affiliated with any organization or company at this point, right? And then Graham is the technical expert on Designate, so he's going to introduce himself and run through some of the slides later with the more details, and including a demo, hopefully. So with that being said, can you go to the next slide, Graham?
Sure.
So before we dig into Designate, what that is, I want to kind of just give you guys also an overview of what OpenStack is, just so you have that background. So OpenStack is a free open source product. Is one of the largest open source initiatives in the world. It takes advantage and kind of glues together a lot of different other open source projects to create a standard cloud computing platform that you can use, right? So you can spin this up internally for your internal users, or you can expose it externally and sell services similar to Azure, AWS. So there's different components in here, right? And for example, if you want to provide compute capabilities, then the Nova project will provide that virtual machines for you. You probably need some kind of network layer to tie into your network, so you can do that with Neutron. And if you want to do storage, right, object storage, you can use Swift or Cinder for block storage and so forth. So you can pick and choose what products and components that you would want to use here. Normally, virtual machines, networking, Neutron, and so forth would be what you would want to do, right? But it's feasible to just run OpenStack just to run DNS if you wanted to do that too. And the OpenStack project itself, it was started in 2010 as a joint project between Rackspace and NASA, and eventually became the OpenStack Foundation in 2012. So there's different developers from all around the world contributing to this, and it's different components, right? So which makes it very easy. For example, Keystone is the authentication mechanism. And if we need two-factor authentication or AD integrated or Radius integrated authentication, then you can make that change in Keystone, and that will trickle through, and Designate or any other project will be able to take advantage of that. So there's components like that, and there's about 20-30 different components that you kind of blend together, as you can see here. So more specifically on Designate, if we go to the next slide, it started as a project just to maintain the DNS infrastructure. And it was used both at HP as well as Rackspace, and I think it's still used there, for their clouds. In 2015, it was moved into the OpenStack Foundation. So what Designate is providing is an API, a CLI, and a graphical user interface so that user can interact and add their own zones and DNS data into DNS. There's no like internal DNS servers inside of OpenStack. So we rely on secondary servers that you set up, such as Bind, to zone transfer out from OpenStack the data that has been manipulated and is being maintained by OpenStack. So that's how it's worked, and we have some graphs and some slides around that. Officially, Bind 9 and PowerDNS 4 is supported, but there's a bunch of other DNS servers that are known to work. And it's not a lot of work. If you have another DNS server that you would want to support, it wouldn't be too much of the work to get it to support. And of course, we support most normal standard resource record types that you can imagine, A, quad A, and so forth. But obviously, some of them would require GUI change, right? If you have some new strange record type that you need to add, and would have to make changes into the GUI and API to make sure that you can add those into Designate. So, but it's not complicated to add those either. So next slide, please. So this is kind of a representation on how the architecture looks like. And as you can see, Nova, Neutron, I mentioned those. Those are the virtual machine and network capabilities. They are utilizing the API so that you can set it up so that, when you spin up a new virtual machine, then based on the name you're setting, you can automatically get that added into Designate, right? But you can also use this API or the graphical user interface to just log in and make whatever changes or add whatever records you want into the DNS, right? Outside of actually spinning up a virtual machine, if you need a CNAME or MX record or anything like that. Graham's going to talk more about the database layer and all the workers and producers and so forth. But what I want to mention on this slide is just that mini DNS, which is a small little DNS server. It's not optimized for receiving queries, but it's rather optimized just to be able to do the zone transfers from your customer-facing DNS servers. So these could be your internal bind servers or your external or both. And they will then do the standard, zone transfers to pull down the data that Designate has prepared in that database. And there's a backend kind of driver to do the reloads and to add new zones and those kinds of things as well that needs to function so that we can communicate to all your DNS servers. And let's say there's a new zone coming up or we need to do a reload and those kinds of things. So you can retain and maintain your old infrastructure. Typically, if you have a bind infrastructure, you don't have to reinvent and build something new. You can just retain that and you can tie that, whatever domains that you're adding into Designate, they can then be managed and be secondary from your DNS infrastructure that you have today. So next slide. So, what are we doing this and why is Designate an important piece here? One thing is that it's great that we have a more open alternative to the commercial cloud services. A lot of people are used to now Route 53 or Azure DNS, Oracle, Cloudflare. There's commercial platforms that are providing these capabilities. And here's an open source platform that mimics that and provides that same type of capability. That gives us diversity in the DNS ecosystem. There is a good alternative for you if you want to spin up your own internal cloud service, right? And it enables your end user now to make changes via simple interface, graphical user interface, or even an API if they want to, do this as a part of a larger workflow to spin up a service and add DNS records and other things. They can do that via an API, via Python. So this, I think, is important because, back in the days we were VIing named.com files and so forth, right? And that's no longer going to cut it, right? So you need some kind of more self-serve capability where users can log in and make their own changes in a safe and secure manner. And then that just trickles through because that's what people are used to today with these external cloud services. On our roadmap and some of the need, and if you're a developer and you're like Designate, feel free to help us with some of those pieces. We're working on shared zones and better being able to share zones amongst multiple users. There's also a redesign of the database layer that is required. It's gone through, it's designed back in the days, and we need to make some changes there. And then always, if you install or use Designate and you want to update the documentation, then that's also very welcome. Some of the elements in there is not super well documented. And another thing we were thinking about, and there is an architecture for, is DNSSEC. So today we don't support DNSSEC, but this can obviously be done relatively easy. If you think about the last slide, that we have that mini DNS, which provides zone transfers. So you can inject kind of like a signer in the middle and sign those zone transfers on the fly, and push them out to your secondaries, so that all the key capabilities for DNSSEC is residing in a separate compartment outside of the Designate itself. So that would be an easy and I think a maintainable way of providing DNSSEC for Designate, similar to what other platforms have been done as well. So with that being said, I'm going to hand over, unless there's any open questions for me, I'm going to hand over to Graham to talk a little bit more about the details of Designate.
Great. I can't see any questions. So my name is Graham Hayes. I was the lead maintainer for Designate for 4 years, and I stepped back to being a member of the core development team last year. So I've worked on this across multiple cloud platforms and private clouds. And the question we always get asked first is, why do we need DNS as a service? Why is there the need for the API? And as Stephan covered before, the new operational practices that are emerging in the world are to be as hands-off as possible, to let tools interact with mission-critical systems like DNS, and using a lot of the configuration management tooling, the ability to inject DNS records fits into the infrastructure as code mentality quite well. So as you're building up your infrastructure, you can automatically generate the DNS records. And it removes the additional step of what we used to have of a service desk, ServiceNow or Jira, and getting that approved and all the way through. And then the next time you do an update to your infrastructure, having to do the same again. So using something like Designate, which is multi-tenant, so you can have the zones are segmented into different groups, so you can have ACLs and allow only the people who should be updating a zone have access to it. Really helps a lot of these automation things move forward. So Designate itself, because it's an OpenStack project, the concept of a project is how we split up resources. So a project is a collection of like DNS zones or networks or VMs or VM images, and users can be added to multiple projects. So they can an operator can be added to multiple projects, and they can see, say, the dev environment, the staging and production, or they could see the 5 staging environments that we're responsible for. And keeping it per project allows the segmentation, so you keep all of the related resources together. So your staging environment DNS records are in the same project as the staging environment VM and network. We now have, we've had an asynchronous API for a long time. When we first started, we waited until every single DNS server had the record before returning. But now we have a async model where people can push as much data in to the API as the API will process, and it becomes eventually consistent on the customer-facing DNS server side. For the vast majority of cases, the zone data is transferred via zone transfer. There's a couple of small exceptions which I will go into later on, but using zone transfers is how we've enabled the async model, and which was kind of important for us to scale to the scales that required for both the HP public cloud when it was operating in the rack space use case. So what happens in Designate when we get a new record or an update to a record is it hits the API. So no matter what you're using, if it's the UI, the web-based UI or the CLI or another external tool, it all goes through the same API. We have a central service that effectively acts as a validation and storage engine. So the API will do semantic validation, so it'll check that it's in the right format, that the record name matches the zone you're trying to put it into, and that if you've given us a IPv4 address for an A record, that it's actually it's a valid IP address. But in the central process is where we validate that you have the correct permissions, that you're not creating a record that would inject itself into a subzone. So if you have example.com and you also have another zone that's internal.example.com, if you try to create an A record inside of the main example domain, that would conflict, it'll be rejected. From when it gets stored in the database, it tells the worker process that there's an update, which in most cases will trigger and notify to the customer DNS server. So to let it know that it needs to go do a zone transfer to get the new information, at which point the DNS server will connect back to our mini DNS. Actually, I'll show it's pretty easier to see in this slide here. The customer-facing DNS server, which is your bind or PowerDNS or Akamai or one of the other supported backends, contacts mini-DNS to get a full zone transfer. And then we have a producer whose job is to make sure that all zones are in sync. So it triggers periodic tasks that contacts the customer-facing DNS servers to check that the serial matches what is in the database and it's what it expects. And it just does that in a loop to make sure that all the zones are in sync. And if it finds a zone that's not in sync, it'll trigger an update event. Is there any questions on that so far? Am I going too fast, too slow?
I have a few questions, if I can just
Sure.
Have my own questions here. And these are so basic that I'm just gonna just go ahead and make a fool of myself. But so I'm not clear in this scenario what triggers the creation of a record. Is it automatic, like when you create a new container or when a new address is assigned, or does this require the administrator to recognize that they need a DNS record and request one?
Sure. So no, it's a good question. It's actually all of the above. So in OpenStack, we can trigger record creation when you create a new VM that has a public IP address. We can trigger the creation of a the record for that, and then also the reverse DNS record. But a lot of people may use other tooling. So for example, if you're using Terraform to build up your infrastructure, you may want to update other records to point at this new server. So that will be done via the API instead of relying on the Nova or Neutron to send to send the request. But in all cases, it all goes via the API. So it depends on what tool you're interacting with. So Nova and Neutron know that there's Designate installed in this OpenStack. This is a public IP address. and it should have this DNS record because of the metadata that was provided when the VM was created. And it can call the API on your behalf, or your tooling can do it, or somebody can decide that they want to create a CNAME or manually create records either via the UI or the API.
Okay, so one of the classic problems with having the records created automatically is it's it's like well, I always think of a roach motel, which is a little box with glue on the inside, and the bugs go in and they never come out again. So this periodic update process that you've described, it seems like there's a real opportunity there. What happens in a lot of enterprises when they have dynamic DNS is, you know, when they spin up a new host, they push a name into the DNS, and then years later they retire that host and the name stays in the DNS forever. So this periodic syncing process, does this also clean up things that no longer are existing in your OpenStack environment?
No, that particular one doesn't, but the Nova and Neutron also they have the removal logic built in as well. So when you go to remove that VM or the network, it'll go tell Designate, I'm going to go remove these. Can you remove the DNS records? So yeah, it doesn't turn into the roach motel of stale DNS records that nobody knows what to delete because it might break something vital.
That's a very
what
cool
I've seen.
That's a very cool feature, because that is a big problem in some places.
Yeah.
And one thing to add there also, if I may, is that, you know, everything within OpenStack is tied into a user, right? So you can at any given point as an administrator go in and see how many DNS records does Wiki have, how many does Graham have, and so forth, right? All that is you know, tied into. So if somebody were to leave the company or something, you can also go look and see what DNS records did they have, and should we transfer them to another owner, or should we just remove them, and so forth, right? So we have that full tracking capability. That
must be where this whole concept, you mentioned shared zones earlier, and I didn't know what the heck a shared zone was. So I guess this has to do with the ownership you're discussing.
Yes, because as I said before, it's generally the projects of the owners. So the way that the authentication works, the way a token is tied to a project, and it doesn't necessarily allow a zone to be shared across multiple projects. So that's what we're working on now, so that when you do, if you have a large central zone that a bunch of different applications need to update, you can share it to all of their projects.
Okay, I did say we'd do the questions at the end, but since we're already talking about questions, Oli has already put a question in the Q&A. How can the customer-facing DNS server be notified of added or removed zones and Designate? And then a follow-on question, do you support catalog zones or something similar? I can explain what that is if you don't know what that is. But so the first question is, how does the customer know?
Yes, so the customer-facing DNS servers, it's really dependent on the server. So currently for us, we call RNDC to tell it to add the zone, and that it provides the list of mini DNS server IP addresses as the primary to go get the information from. With PowerDNS, we call the PowerDNS API with pretty much the same information. We don't support catalog zones. That's the? I don't think I've heard that phrase.
Yeah, that's a feature I know. I think it's an RFC at this point, where instead of using the backend to communicate, there will be kind of a catalog zone saying, here's all the zones that you should be secondary for, and then you could remove that top backend
that would be
interaction,
awesome.
then, and you can just use the catalog zone to do it, right? So definitely a great idea to support catalog zones, and something that we probably want to look into, see how we can get support for.
Yeah, definitely. That would actually
architecture.
It would simplify a lot of our stuff, a lot.
It's not. It isn't really standardized yet, though. So that's
right.
At the moment, yeah. It's a bind feature, realistically. So why don't you keep going, and I'm sure we'll have more questions later.
Yeah, I can keep an eye on I have the Q&A open on the side, so I can. If you ask your questions, I can answer them as I go through as well. So that's the overall of how we work. We also have the concept of pools. So a pool is a collection of DNS servers, and then each DNS namespace there's a namespace per pool, which allows you to do a couple of things. So it depends on your use case, but you may have different tiers. So if you're running a public cloud and you're charging for your DNS zones, you may have a free tier that's hosted inside your own network, and then a premium tier that you have different POPs around the world to act as a front end for users. Or it may be for different networking visibility. So if you're a company, you may have an internal set of DNS servers that are only accessible inside the intranet, and then you want to manage your externally facing zones as well. Or if you expect that you're going to have an extraordinarily large amount of zones. There was one user Designate that had like I think it was over 1.5 million zones in one set of DNS servers. So the sharding was what they were really interested in, because it would allow them to spread the load across multiple servers without fairly easily. So each when you create a zone, there's the ability to provide scheduling hints that helps you choose the zone. So you can say, I want the gold tier or the internal visibility, and the scheduling is done off a simple key value pair matching that makes it fairly easy for the end user to figure out that they're going to get the correct pool of servers. And then if your company has any particular requirements, adding extra scheduling rules is fairly simple. It's a explicit plugin point within Designate that if you want to have access to influence the scheduling, if you want to weight different pools different ways, or you want to ensure that some particular pool is only used by the correct people, you can add in custom code there very easily. So the core of our async model is around mini DNS. So it's a small Python binary that has direct access to the database. So when it gets a zone transfer request, it queries that zone out of the database, builds up the response, and sends it. It's not designed to be end user facing, so it's not particularly efficient, but it should never be under massive load. And because, as I'm going to explain later, pretty much everything we have scales horizontally. If you get too much load on a mini DNS server, we can just add more. And it can use TCID keys to make sure that it's sending to the correct servers, and that it's giving the correct view for, say, if you have example.com in 2 different pools, the TCID key from the different servers will identify which pool the request is coming from, so that the mini DNS server can look up the correct version of the zone. So a lot of this is based around database replication, and our high availability and disaster recovery is based off this. So this is pretty much everything that we use. Everything scales horizontally. So as you need capacity, you can just add more API servers behind a load balancer, or if the central is having problems doing the validations, you can scale that out. Each component talks to the others over RabbitMQ message bus. So if you add more nodes into the cluster, it will just start chewing up the messages off RabbitMQ to take the load. And then, so the central and mini DNS are the only two components that talk to the database. So your database is one scaling point. So that's we currently support MySQL or Percona, and that can scale. That's a known scaling pattern. So as part of this means that we can have a DR setup, so disaster recovery setup. So if you have site A as your primary site, all of the API traffic going there, using database replication to site B, there's always a copy of the database at site B, and the mini DNS there can actually serve requests as needed. If the site A disappears, swapping the DNS record or your global load balancer to point to site B to the API server running at site B, and turning the database in site B as the primary, it can then take over seamlessly. Because we don't sit in the data plane critical path. This means that there's no actual downtime for the DNS server side. So while users may not be able to update something, they're still the records are still being served, which is important. This allows us then to have satellite pops as well. So say you have a main site in New Jersey that's serving, that's where the API is, and it's storing to the database there and pushing out to DNS servers. It can also be doing replication to a database in a satellite pop, say in Europe somewhere. And then the servers that are sitting in that pop can be configured then to pull their zone transfers from a mini DNS sitting there connected to the replica database. So you can avoid sending the zone 3 times over expensive WAN link. You just replicate the database changes to the site, and then the traffic is all internal. So for the most of the usage, I'll be doing a demo at the end of this, but we support by9 and PowerDNS. So they're the main servers that are supported. We test every single commit that goes into the project is tested against those two. And if the way that the CI system is set up in OpenStack, if it fails, there's no way it can merge. So those two are the guaranteed working. We support Akamai, the new Akamai APIs, InfoBlox, and the Microsoft DNS server. They're all relatively tested. There's people I know using them. And then we have experimental support for not DJB and GDNSD. The work is all I say experimental. I wouldn't rely on it for production work, but if anyone's interested in expanding the support or pushing it further, it's definitely something we'd be interested in seeing. So yeah, the versions of by9, we test against the versions in the Ubuntu and Fedora operating system repos. We don't use any particular features, so as long as it supports an RNDC call to do a create, it should be supported. I haven't seen anyone complain that we are using a feature that isn't supported in a very old version of by9. a lot of our work hasn't changed that much when dealing with bind or PowerDNS. And there's a full list of the different supported servers and a link to their docs at the bottom of the screen there. So adding server support is pretty easy. So in the previous architecture diagram, this one here, the backend here, this backend is a pluggable piece of code, and it has effectively 3 methods. So a way to update a zone, create a zone, a way to delete it, and then if there's a special thing that needs to be done to do an update other than sending a notify packet, that gets put there as well. So for example, like the PowerDNS driver with their when they got to version 4 and enabled the API, I think the entire driver is about 25 lines of code. And we're always open to expanding support for DNS servers, particularly open source DNS servers that we can actually run and test as part of our CI pipeline. But we are open for everything. So we have commercial, we have Akamai, and we have things like InfoBlox in there as well. As long as they support using a zone transfer to get the information. For the edge cases that don't support zone transfers, so the one that would spring to mind mainly is like free IPA or Cloudflare without an enterprise account don't support zone transfers. So there's a binary called a Designate agent that can receive the zone transfer, and then the driver can decide what it wants to do with that information. So if it wants to do a diff between what's currently stored in the provider or in the DNS server and then what it received and send an update, that way it can. It was mainly provided because we didn't want to remove support for some of the providers we had that needed this, the diff method, but we, because of our async model being reliant on having the having the zone transfer be the basis for pushing out content, this was a compromise that was done to allow it to happen. Incidentally, if there's anyone from Cloudflare who wants to donate an enterprise account to do to create a driver for the secondary support in Cloudflare, do reach out, because that is something that would help us with our adoption as well. And then for the external API, there's, as I said before, there's a lot of different ways to interact with OpenStack, the DNS service. So if you're using things like the Let's Encrypt service, there's a plugin for certbot that supports OpenStack. There's full support in Terraform. So if you have a config management system in Terraform or Ansible, the Designate can serve as the API endpoint to go update and create DNS information. There has been recent additions so that when you create services or load balancers in Kubernetes, that the DNS information is auto-populated, so it works straight away via an external DNS operator, and so it can read the load balancer and service creation and push the DNS information out. And then there's OpenStack Heat is an orchestration service. So if anyone is familiar with AWS, it's roughly equivalent to CloudFormation, where you can have a template of resources and when you want to create them, you can post them to a service and it'll manage the sequencing creation and deletion of different resources. So you can build in DNS into your infrastructure from the beginning. So if you want to have multiple servers fronted by the same A record, you can create the servers, have the IP addresses created, and then put into a record in the heap template, which means that there's a single create command for your entire stack. And as we talked about before, when you create and delete virtual ports on a network within OpenStack, so when you when you create a VM, you can have the networking service reach out to Designate to auto manage the creation and deletion of both forward and reverse DNS records, which is one of the advantages, especially for cloud providers or internal, for private clouds that serve multiple groups within a company. The managing reverse DNS is complex, and allowing self-service for reverse DNS generally involves either ticketing workflow or some internal tool that's built to manage it. So I am going to show us an example of Designate. So I have a development environment running on the box beside me. So let me swap to that. So is that visible?
Yeah.
Great. Sorry. I broke routing within the house. So we can have a look at the zones that are currently available. So it's one I created earlier. But if we want to do, say we want to create a new zone, so this is going off to create the zone and push it out to a bind9 server running locally. So it's been created and it's automatic. It's been pushed to the internal bind server. So we can then
Your commands are off the screen, Graham. Can you scroll up a little bit because I can't see what you're typing right now.
okay.
And this is, this is the CLI, right? So Graham could also do this via the API or the graphical user interface, right?
Sorry. Yeah, so I've actually have an example of so this is a example. So this is what I'm posting to the DNS server. So this is the JSON snippet I pushed, and I am unauthorized. There we go. So this has gone and created that record. Our DNS, the API is relatively simple. Part of the reason my CLI skills aren't great is because I actually tend to end up using curl or HTTP a lot. But it's very, very automatable and easy to deal with. And it also has tools like, so we can list all the records in our entire install that have are pointed at 10 dot whatever. We can do wildcard patterns on that. So this is searching across all projects, so it's across all of the different records and all zones. And because we have pretty solid access control, we can reserve that for administrators only, for example, or we can have project administrators that could search within their own project, but not across all of the different projects in the install. And finally, let me open up Firefox. So this is the example of the, I've definitely been logged in it. So we can see the zone I created earlier, and we can look at the different record sets. So we didn't create anything there, but and it's gone and created it. So we can see that it's pending while the customer-facing DNS server is being updated and pulling the zone. And if we refresh, we'll see that it's now active. So as soon as Designate confirms that all of the servers in the pool that this zone is on have the correct serial, it'll mark the zone as active and ready to use. Is there anything anyone else would like me to run through in the UI? Anything anyone wants to see in particular?
Very cool. That is clearly a working demo. I was curious, it seems to me like if you are making it really easy for people to create new DNS entries every time they spin up a new application or container, you might have a high volume of very short-lived entries. Is that a thing, and have you had to do anything to accommodate that? Particularly, you know, some of these big cloud environments, I would think there'd just be an awful lot of turnover.
Yeah, so that's a lot of the reasoning behind mini DNS was to get around that, was so we could use the more efficient database replication to the edge points, and then the zone transfers would be done on the super fast local links. For the short-lived records, we haven't really had much issue. Honestly, I did expect to have more, but it seems the system is scaling. We have some pretty small defaults, but they seem to scale out fairly well with the ability to add with using the database replication and using that method for pushing out the information.
Anybody have anything else they want to see in the demo? You did mention something in your FOSDEM presentation that I thought was interesting. OpenStack has kind of a reputation of being a lot of software.
Yeah.
And you said that you were, running the whole thing on your laptop, I think. So that might just be interesting to give a sense of roughly how much you have to install to get what we just saw.
So what's installed for what you see right now is Designate, obviously, the Keystone service, which is the authentication service, which itself is very lightweight, and the Horizon, which is the web page we're looking at right now, which is a simple Django app. So my personal installer Designate is run on a dual core Scaleway ARM box. Now, there's not a huge amount of zones. There's maybe 80 different zones on it, but it's running on a super small machine. The current demo is running in a dual core VM with 3 or 4 gigs of RAM. So we're not, overall, you don't need a huge amount. Like Stephan pointed out in the beginning, you take the bits of OpenStack that you need. So if you just want DNS services, you need Designate and Keystone. And then if you want to add a nice UI for your users, you need the Horizon. But that's all you need in the beginning.
But you need a database as well, right? So
yeah, so there's database, there's a MySQL and a RabbitMQ, and they're all hosted on the same machines for me in my installs. So I have 2 of them running for HA, but it's active passive.
Graham, can you show or give us an idea on like what software you need to install? Like you using PackStack or DevStack or something like that?
So yeah, I'm currently using DevStack for the demo environment. There's a lot of really good installers for OpenStack that allow you to choose the software. I'm partial to OpenStack Ansible personally, which is it's an Ansible-based installer that builds up the base things required. So things like the database and the RabbitMQ servers, which you can reuse across all the different components. So you don't have to have a separate MySQL server for Designate and Keystone. You can use the same server and have just different databases on it.
Yep. So those DevStack projects and PackStacks, and there's a few of those that makes it fairly easy to install.
Yeah.
On a smaller environment, non-production type of environment, if you want to test or you want to develop, right? So you don't have to install, SQL, everything separately. Like kind of pulls everything down for you.
Yeah. So this is the installer I used for the demo environment I'm using right now, and it has a good set of docs here that you can read through, and it's good to set up if you want to learn how everything fits together and understand that. It's a good starting point. The only caveat I would say is don't run it on your local machine. Make sure you run it in a VM, because it assumes that it has total control. So it will spew Python packages everywhere, which could be detrimental if it's your desktop. Okay.
I'm just thinking back to the GUI you were showing us where you're looking at the zones. So the DNS service that you're pushing these to is probably getting zones from elsewhere as well, right? So the OpenStack will be a subset of the zones they're publishing.
Sure. Yeah, they can be. It depends on your setup. People do set it up that Designate only manages a portion of them. We have a support for allow and block lists. So you can say that designate records must be of this must be inside of this pattern or cannot be this pattern. So if you know you have a set, like you have an internal production zone that you don't want designate to ever be able to create, you can put that onto a block list. It's a simple regex list that will block anyone creating that zone and pushing it out. If the zone already existed on the server when designate tries to create it, designate will fail and say it already exists and here's an error.
Right, I actually remember when we improved our NDC to let you know whether the error was because the zone already existed or didn't exist versus a communication problem. Once upon a time, when it failed, you couldn't tell which it was. Okay, well, we'll just have an awkward pause for a minute here and see if anybody comes up with any questions. Otherwise, I really appreciate the time you guys took and the effort to put together this lovely deck and the demo. I think it's a very interesting option for people looking for a management front end for their DNS.
Yeah, and so yeah, here's the set of
but you know.
Here's a set of links for the code repo, the docs. We sit in IRC on Freenode in OpenStack DNS. And the mailing list is where a lot of the discussion happens. So if anyone has any questions, please feel free to reach out to us. I'll add my personal email to the slides that get put up as a PDF if you want to reach out to me directly.
Okay, well, I think that's it, and it doesn't seem as if there's any follow-up questions. So thank you very much, and have a great day.
Thank you.
You too. Thanks for having us.